We're now going to rationalize any radicals from the denominator. I did one earlier with square roots. So to review, if I asked you to rationalize this particular fraction, keep in mind we never want radicals in the denominator. 10 radical 3 over 9 radical 2. So to do this, I'm multiplying top and bottom by radical 2. And radical 2 over radical 2 is like a 1, so it doesn't change anything. So now I multiply outside of jail 10, inside radical 3 times radical 2 is radical 6. Outside here 9, radical 2 times radical 2 gives me just 2. So this is 10 radical 6 over 9 times 2 is 18. Now the last step is we have a 10 outside, as I call it, outside the radical, outside jail, and the 18. We can reduce this. 2 goes into this 5, into this 9, and our final result is 5 radical 6 over 9. Now we could do this because radical 2 times radical 2, it takes 2 of them to break out of what I call square root jail. Let's do one where it's not a square root. So I now want to simplify 5 times the cube root of 2 over the cube root of 9. Now in this case it's not a square root, it's a cube root. So if we think of the idea of jail, it takes 3 of them to break out. I can write this is 5 cube root of 2, but cube root of 9 is just 3 times 3. I already have 2 3's here. I need just one more 3 to get that out of the cube root. So I'm going to multiply top and bottom by cube root of 3, cube root of 3. This is going to give me 5 is outside jail, cube root of 2, cube root of 3 is cube root of 6. But now we have 2 and 1. We have 3 under the cube root. They break out, and you have just plain 3. And that becomes your answer. And we know that's correct, and because 3 is outside of jail, 6 is inside, we can't do any other canceling. We'll do one more, only this time I'm going to give you one where I ask you to simplify 2 times the 4th root of 3 over the 4th root of 20. In this problem, I don't know what I'm dealing with, so the first thing I have to do is look at the prime factors of 20. So 20, 2 goes into that 10, 2 goes into that 5, then we go to the next prime, 5 goes into that 1. We are dealing with a 4th root. None of these are the 4th root. But we're going to be able to put these prime factors instead of 20. So I'm going to rewrite this. We're going to get a rewrite. And I write it, it's 2 times the 4th root of 3 over the 4th root of 2 times 2 times 5. But this is 4th root jail, so I need 4 of each prime in order for it to break out. So I can see that I am going to have to multiply top and bottom by 4th root. I need 2 more 2's, and I only have 1 5. I need 3 more 5's. And the same on the top. 2 times 2, and then I have the 3 5's. So now we're going to multiply the top. We've got a 2, and then we've got the 4th root of, well, I've got 3 times all of this. I'll put it just in factors. We'll actually multiply it in a moment. Over. But the whole purpose of doing this is we now have one group of 4. So that comes out of jail. We get a 2. And then we got a 5 and 3 more. Another quartet, which gives us a 5. Now we can write this as 2 times the 4th root of, well, I'll go like this. 3 times 2, 6, times 2, 12. 12 times 5, 60. Times 5, 300. Times 5, 1500 over 2 times 5 is 10. We're almost ready, but in this case we can see the 2 outside of jail cancels with the 10 on the bottom. So our final result, this cancels with this. The final result for this is 4th root of 1500 over 5. And in jail can't cancel with the 5 outside of jail. So again, what we have, we knew up here we did not have 4 of anything in the numerator, so they all get multiplied. And that's our answer.